Hello, Mr. Adam. Here's the video I promised you about how I process DSLR images using PixInsight. So first we'll fire up PixInsight. Oops, that's what I was working with. And the first thing I do is I open up all my tools that I'm going to play with. So this is most of them. I'll go through each one at a time and kind of show you how it works. Before we get to that though, I want to just show you some of the file handling and general flow. So the general workflow that I use to process DSLR images is first I figure out which subs I want to stack. Obviously some of them need to be tossed. Rarely do I hit 100% efficiency. To do that I use two tools. One is called Blink, the other is called Subframe Selector. And then after I know which ones I'm going to stack, then I actually stack them. I have to crop out stacking artifacts. Then I do my gradient removal. So this is the magic of PixInsight. This tool alone is almost worth $200. It's fucking ridiculous how awesome it is. It will take care of light pollution like no problem. Sometimes if you have good DSLR images, you can do deconvolution. I never had good luck with that. So for this particular Leo triplet image, I'm not gonna do that. Then we stretch the histogram, wipe the green, because the Bayer array is red, green, green, blue, so there's excess green. Get rid of that. Then we'll calibrate the colors, so it doesn't matter if they're all wonky and shit during the previous 7 steps. Who cares? We'll neutralize the background. So in addition to getting rid of gradients, we'll also make sure it's a nice even toned balance of red, green, and blue. We'll do a little bit of denoise. I usually use TGV. Works pretty well, but there are lots of other denoising techniques, ACDNR and stuff that I don't really have a lot of experience with. And then last, I do the final tweak. So I do local histogram enhancement. This is also PixInsight magic. Color saturation, and then curves. So things like 12, 13, 8, even 7 can all be done with Photoshop, but 4, 10, and 11, those are pretty much PixInsight exclusive, and they are worth it. So that being the case, let's get to our images. So File, Control Open. Here's where I have all your data. So I put all my data here. Let me just show you. Just have these are fences, by the way. I recommend you use them. All my data go into AP, organized by category. You get your own folder. So here are your post-flip lights. Here are your pre-flip lights. These are my processing attempts. This is that processing flow, and this is the raw data zipped up. So I could probably actually delete those now. All right. So we'll go to PixInsight, open up. What I want to do first is I like to do the blink tool first. So when you go over to the Process Explorer, there's a couple ways you can open up tools in PixInsight. You can go to Process, and it lists them all out. And if you go to All Processes, these are all the choices. These are all the tools that PixInsight has. So you just click on the one. They're in alphabetical order if you didn't notice. Or what I do is you make a favorites list. So right here it says favorites. So these are the ones that I actually use out of all those ones that were available. So you double click Blink, and it'll open up this guy. And then you click the little folder that says what is it you want to look through, and you load up the files. So you just select them all and hit open. It takes a few minutes to do so for DSLR files, so I already have them pre-opened. You can do, I do the pre-flips and the post-flips, load them all up together. When you do so, the blink tool will open up a box. And the cool thing about the blink tool is that it takes every single one of these files, so 1, 2, 3, 4, 5, 6, 7, 8. These are the pre-flip files in this case. It takes every single one, puts them into the same window, and does the exact same screen stretch. So basically it does a fake histogram stretch to make it look like what the image would look like if you were to stretch the histogram. Right? So if you click this little button, it'll turn it off. This is what the raw data look like as of right now. If I scroll through all the images, my computer's a little bit slow because I'm running a couple things at once, right? If I scroll through all the images one at a time, it will, they all just like black, right? So this is essentially the raw data. So if you click the little, what PixInsight calls it is a screen transfer function, STF. Basically, it just changes the histogram, or it changes the way the image looks as if you were going to stretch the histogram. That way you don't have to actually modify the data to see what you're doing. So when you click it, it'll do a little calculation, done. This is what they all will look like. Now blink is called that because it will literally blink through all the images. So if you hit play, if my computer actually worked, hear it cranking away. It's do something in the background. I hope the combination of PixInsight and Camtasia, my screen recording software, is not too much for it. Alright, it will slowly hop through each image at about 0.3 seconds per image. You can see it's laggy here. And it stretches each one and shows you what you got. Right, so there we go, now it's going. So it just blinks through, blink, 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 blink. So you can obviously tell just by looking at this. For example, look at this star up here. You could see how that star changes full width half max, changes diameter as you hop through all the images. So if this is enough to decide if you want to keep or delete a frame, that's fine, you can do that. If you want to take your time and look at each image a little bit longer, like a second, you just change the thing and say, oh, okay, 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 okay. Or if you just want to quickly scroll through and just crank it out, you just say, what does it look like? Okay, they all look pretty good. There's no outliers that are blatantly standing out. Okay, so I've done that, and I did that for your pre and the post. And then the next thing I did was a tool called subframe selector. So subframe selector is actually a script. It's not a tool, so it's not a process. So if you go to all the processes, these are the tools, so to speak. The scripts are up here in script, and there are a whole bunch of them. Each little gear is a particular script. Basically, it's a JavaScript standalone kind of plugin, if you will. So batch pre-processing and subframe selector. You click that. The subframe selector tool will load up your files, or you pick the files you wanna select from. Okay. I've already loaded your Leo triplet, and I've done, let's see, it looks like these are the post flip ones because there's 14 of them. And you hit the button measure. When you hit the button measure, I don't want to actually do it right now because it actually does a bunch of calculations. It will generate a table right here that has all these categories. It has the name of the file, it has the weight of that image, it has the full width half max in pixels for the average of all the stars, it has the eccentricity of the stars, and this is an important measurement because the eccentricity tells you essentially are they round or not. So a good eccentricity is like under 0.2, I believe. As they start to egg out, they get to 0.5, 0.6. As they get to like real ovally, they get to like 1 or beyond. So I've already done this, and after you generate the table, after you hit measure, it'll do the math. Let me just do one of them real quick. So I should be able to do, boop. I'm just going to disable all these guys. So I'm really only going to measure one frame, just to give you a feel for what it looks like. Okay, so hit measure. It'll do the measurement. It was nice and quick, so that's good. And you can see it says here, the weight, the full width half max in pixels is 1.7, the eccentricity is 0.5, that's not bad. Signal noise ratio, weighted, 6.1. I'm not sure how it gets these numbers, honestly. And you can see there's tons of shit here that it uses to do these calculations. The cool thing is you can do save table as and output the table, and I've done that right there. It'll save it as a CSV file, so you can always, keep these statistics of your data, and you can say, okay, I have 10 files. What if I toss numbers 1 and 6? What will my data look like, etc., etc. So when I open it up in OpenOffice, gives me some actual numbers about my data, or your data. Right, so here are all the subframes down here, and then here are the values that we're interested in. The weight, the full width, half max, the eccentricity. So essentially what I do when I do my subframe selector is I just go to this column and I look for numbers that are abnormal, right? They're all about 1.8, 1.7, 1.8, 1.8, 1.8, 1.8, 2.3, 3.0, 1.9, 1.9, 4.8, right? So this guy, this guy, and this guy, and this guy I would toss. That's how I do this. You can look at the eccentricity, 0.61, 0.6, 0.55, 0.53, 0.57, 0.7, right? Clearly that's an outlier, and it matches up with this number being absurd. If you remember this image, this is the very last one of the night. It was taken at 6:11 in the morning. Sunrise was at 6:18, so that's probably why that number's all wonky. Your guide star got all screwed up. So anyway, you can look at those numbers in very gory, stupidly large detail if you want, but that's basically my hand-waving method to say, okay, I'm going to toss out the image from 6:11 and the image from 5:28 and 5:39. So I'm going to drop 3 subs out of that list. Okay, so I've already done this. I've done this for all of your frames, the post-flip and the pre-flip. When you close a script, yeah. And I figured out, okay, I know which ones I want to stack. To stack, you go. There's 2 ways to do it. You can do it automatedly, which is the way I normally do it. Which you go to batch pre-processing, and batch preprocessing. This is really neat because you just load your bias, your darks, your flats, and your lights. So you go to add lights, and you go to the lights and you say, I want to load all of these guys, right? All the stacking parameters are here. If you want to do cosmetic correction, you want to try and get rid of hot pixels and stuff, you can do that. If you want to do image registration, which you will need to do, image integration, this will actually integrate them. You have to say which registration image you're going to use. So you pick one of these and say, this one will be the main, all the others will get matched up to that. So since you went to blink or since you went to the subframe selector, you know which image is the quote-unquote best based on the full width half max value being the smallest, and then you say, okay, everyone match that. So I'll just pick, this one, whatever, it doesn't matter. Output directory, this is after it does all the stacking. Where do you want it to store it? I just usually make a folder every time I do go through this entire process, V1, V2, V3, for as many versions as I have. And then hit run. You can also hit diagnostics. We'll say, hey, you forgot to include bias. Hey, you forgot darks and flats, etc. This, for some reason, this didn't work for me. You're doing RGB images, like one-shot color, so you have to enable CFA. For me, I do optimized dark frames, which allows me to use a dark frame that's longer than the light frame. And then I have a master bias dark and flat, so I check all those. And when I go to flats, I just load the master. I don't have to load them all. So I don't have to remake the master flat every time I do a processing. So I can reuse my bias, my darks, and my flat library over and over and over again. Okay. So this is the automated way to do it. You hit run and it does it. The other way to do it, which is the way I had to do it for your data set, I want to exit, is through a combination of two tools, star alignment and image integration. Okay? Star alignment just takes a set of images and registers them to each other, right? So it just says, here's the images that I'm going to register. Here's where I'm going to put them once they've been registered. Here's the file that I'm going to match them all to. So basically you pick one out of the X number that you're stacking, and it will take them all and rotate them and flip them and do everything it needs to do so that it matches this. And if you notice, there are 19 total frames here, whereas in your data set you have, how many did you have? You have 14 files here in the post flip, and you had 1, 2, 3, 4, 5, 6, 7, 8. 8 there, so that's 22, and we tossed out 3, so that's 19, right? And that's how many we had, 19 files. So that's where they come from. So that's all of the files that you want to stack, even if they're on the other side of the meridian. Tell it where to save it, and it will save it with a little postfix, which just a little, it'll save the file with _R, and it also by default saves it as a fit file because it's more efficient for PixInsight to do stuff. Okay, so you save that information. I usually leave star detection, star matching, and interpolation. I usually leave all this stuff as default, and it works just fine. So you hit the little green circle, which means do it, or a little square that means do it, or you click and drag a little triangle onto the thing you want to do it to, and it will align all of the files. It won't do anything to them, it just aligns them. Okay, so if we go now to your data set, and I'll show you what I'm talking about. There you are. And I think I stored them here. Nope, I lied. Here we go. Nope, I lied. Where the hell did it go? Oh yeah, here it is. So under version 1, right, it's the same file, but it now says _R and then fit. So what that means is that these guys right here have all been registered to each other, so they're ready to be smashed together in a stack. So the alignment step, or what they call registration, is different than the actual stacking step when you do it manually. So to actually do the integration, or to actually smash them together, you have to use the tool called image integration. So then you load up the files that have been registered, right? And that's where you actually do it. So this is where you change your stacking method to either whatever method you want. I like to use iterative k-sigma by weight mid-variance. I have no idea what that means, but it works, so I use it. And under pixel rejection 1, Windsorized sigma clipping. This will cut off the hot and cold pixels, right? You can read all that text if you want. I usually don't bother with pixel rejection 2 and 3. You hit the little circle, apply global, and it will actually smash all your images together. So once it does, you get an output that will be oh no, I hope I saved it. This. Okay, opening up the DSLR file, you can see how long it takes, like 2 seconds. This is what it looks like. So the screen transfer function is the way that PixInsight shows you what your data look like without actually modifying the image. So you go to the tool called screen transfer function, double click it. It's this little box right here. You click the little radiation symbol. I have no idea why it's that symbol. It's just that's what it is. And it does an automatic stretch and displays what the image looks like. So this is your image, and you could see how fucking terrible not having flats, what it did to your image. So you could clearly see that this box in here is due to, let me just make this a little bigger. This box in here is due to the frames not overlapping, and because you don't have flats, it's not flat all the way to the edge of the field of view, and so we're going to have to do a pretty heavy crop on this. Okay, so coming back to our list, we parsed all the subs and we did the stack, so that's done. Now we're on step 3, crop. To crop, we use a tool called dynamic crop. So go over here, dynamic crop, and you select what you want to crop. So dynamic crop. I don't know why it's weird the way it works. Like once you open the tool, the first thing you click on is the thing that gets cropped. All right, so I'm going to crop maybe, we'll say like that, right? And once I select it, if I want to say, oh, actually, I don't want to include that reflection, and I don't want to include that reflection, and maybe I want to go a little bit further down here, maybe like that, and then scooch this over just a touch, so I'm cropping out all this shit. Let's just say that was my crop, right? I can also move it around if I want. Let's say that was good. Green check mark means go. Now what I do is I immediately save this, Control-Shift-S, as under version, this example will be version 3 because this is my video example. Right? I take the name and I append cropped, right, as a TIFF file. That's what I do. Most people I don't think do this, but I like to do things a little bit more manually because I like having control over the system. If you go down here to History Explorer, right, and just click on it or hover over it, select the view that we're talking about. The view is called pre-post stacked, right here it says pre-post stacked. This is the name of the view, and this is the name of the file, right? So the view and the file do not have to be the same name. I'm not sure why it does that, but whatever. So we'll just call it this. See, it started out here. The first thing I did was I did dynamic crop. Right, so this will keep track of everything you've done to an image as you do it, but I like to do it manually and then save the file as a separate file name. So depending upon your hard drive space and that kind of stuff, you do it any way you want. Okay, so we got a cropped image. So step 3 is done. We got to do gradient removal. So ABE and DBE, right? This doesn't look too bad. So to remove gradients, you can use a tool called dynamic background extraction, DBE, which is really good. Oops. Dynamic crop is still open. You can only have one dynamic thing open at a time. Or you can use automatic background extraction. ABE usually works pretty well for me, so that's what I use, but you might want to tinker around with the other ones. There's tutorials online for that. So one thing you do want to change is the correction. You want to change it to subtraction, and I don't like it to replace the image because I like to resave the image. All you have to do is take your stacked image, click and drag the triangle onto it. It'll actually do the event. It's pretty quick. It will subtract the event, and then I have the settings such that it shows you. Okay, so this is what your background looked like. It's kind of gray. You could see the vignette pattern. It's not too bad. Right, and this is the new image. If you notice, the file, what do they call it? The view has been changed. The view name has been called pre-post stacked ABE, but it doesn't really have a file name yet. So what I do is I immediately save this as pre-post stacked, right, cropped ABE. Right, so now I have two separate files. I have this file, non-ABE'd, and I have this file. Now it doesn't, I haven't done the screen stretch yet, so I have to click the screen transfer function, and the shortcut to doing that is by hitting Control A. So there we go, there's our Control A, and I'm done with this tool. What I do is I open up all my tools and I throw them over here on the right side, and after I use them, I just slide them up here. So I know which ones I'm done with, and then I know which ones I still have yet to do. Okay, so this was the pre-background extraction. This is the post-background extraction. Right, you can see the difference. The vignette is gone. There's this weird thing here showing up. You could do multiple iterations of background extraction if you want. Whatever you want to do. So I'll close this. So background extraction gradient removal is done. Deconvolution is next. I'm going to skip this. It's a whole thing in and of itself. I don't know if your data really need it anyway. So next step is to stretch. So to do a histogram stretch, remember this is just what the image looks like. It's not actually stretched. So if you open up the histogram tool, histogram transformation, and you open up the screen transfer function, give an example of what this is doing. So here's your image. This is the reset button. This is what your image looks like. These are what the data suggests. If you hit the auto stretch, this is what the PixInsight suggests you should do for your stretch, right? So what you can do is you can change the view to your image, right? And you could say, okay, if I did what the screen transfer function is telling me right now, I wouldn't be changing anything, so my image looks the same, right? Black and black. If I do the auto stretch, right, this is what it would look like. So by taking this little triangle and dragging it to this bar down here, it says take these settings and apply them to the histogram. Now if you do that, you're applying stretched settings to a fake stretched image. So you have to reset the fake stretch. So this is the actual image. This is what it will look like, right? This is just a real-time preview. This little circle is turning the preview on and off, right? Of if you drag this triangle or if you hit the square button, what it'll do to this image, right? So the image is linear right now, and it's actually doing the stretching event. Now it's no longer linear. And I save this as pre-post stacked cropped ABE. This was, I use just stretched. Okay, and I just do 32-bit floating point, no compression. If I go to my History Explorer and I click this, right, because I'm saving and creating new files every time, it doesn't keep track. But if you just work on the same file, which I don't like to do, it will add all those things in there. So I never use the History Explorer, honestly, because I do everything manually. Okay, so now I have a stretched image. So 6 is done. Remove the excess green. So you can see in here and in here, there's like all these green casts and stuff. I'll just minimize those. Green is removed through a noise reduction tool called SCNR. You can pick a color, red, green, and blue, and if you have excess of that color, it will get rid of it. The default settings usually work pretty well, so let's just take a quick look. It just wipes excess green, so everything will look a little bit more blue, I think, if I remember. Or purple, that's fine. So, Control-Shift-S, after I stretch, I do SCNR. So if I don't like what I've done, I just close this image and open up the previous version. And since the file name pretty much always grows, so here's my file names. So this is first, second, third, fourth. Like the file name just gets bigger by one tool name each time. I know what the previous thing is. This is the current one that's open. This is the one where I did everything except SCNR, right? This is why I use that system. Okay, so SCNR messes up the colors, but it does get rid of the green, right? So that's fine. So remove green, done. Color calibration is next, and background neutralization. All right, so before you neutralize the background, you have to tell it what is white, what is black, right? So you have to make 2 previews. To make a preview, you can go to Preview, New Preview, and we'll just call it 1. And it asks you where you want to put it. Oops. Right, and it makes a preview. I think that's kind of a dumb way to do it, so I'll delete that. Instead, you can just hit, oh no, it's got a little, there it is. Instead, you can hit Alt-N, and you get a preview. So, let's see, we'll do Alt-N. You can see that little symbol, that little piece of paper looking thing shows up on my cursor. And that looks like a nice area of sky to define as the background. So we're doing color calibration. Here's the tool. And we got to define a white area. So essentially, since we have galaxies, we'll go to the galaxy and say, this is white. Now notice I do have a little bit of background in there. The PixInsight will extract the structure. It'll recognize that there's a galaxy in the middle and that galaxies should be white, and therefore that will be the definition of what white is, and preview 1 will be the definition of what black should be. So for the reference image, the white reference, it'll be preview 2. So I just select preview 2. For the background reference, what the background should be with no things in it, you can see it's preview 1, hit OK. Even though there's like a few stars in there, that's okay. It can select those stars and delete them. And then you can either click and drag the triangle to the thing, or you can hit the square. I'll hit the square. Okay, it's doing the color calibration. Color calibration is done, so now it knows what white and black are. And of course, if I have it, _CC for color calibration. Now I can neutralize the background. So that's done, that goes there. Oops, this is done as well, that goes there. Background neutralization, I can use the same preview, so I'll use preview 1. Preview 1, okay. And I could fiddle with these numbers if I want. I never bother to do that. Apply these settings inside this tool to this image. That's what clicking a little triangle onto the image does. And you can see the difference. So first thing I do is save it as, this was background neutralization, so I just use BN. And then I'll open the previous image. Oops, okay, so this is the one that's open. This is the one that I just did. This is the tool I'm now done with, so it goes up here. So this is the one I just worked in. So on the left is my neutralized background. On the right is my non-neutralized. You can see the right image looks kind of more reddish purplish, and this one is more of a even toned grayish. I don't know if you could see, there's like a big light area here and a big like whitish circle. You're flats, dude. You gotta get flats. Anyway, so background neutralization helps. Let's see, what else about background? Oh, like, so say I wanted to examine a star or something, right? So I go here and I'll say, I want to look a little closer. You can just mouse scroll up or down, and here's all your noise, and then obviously your stars, right? So let's say I wanted to look at this star. I just take this little tab, click and drag, and carry it, and hold it on top of this one, and then let go, and it will match the image, right? So you could see, look at the background here, look at the modeling of the color, and then look how the modeling here. You can see how much more red shines through, and how it seems much more red heavy in this image compared to that image. So I think background neutralization was good in this case. Of course, if you think otherwise, you can just undo it. Okay, so background neutralization is done. So that's CC and BN. Next is denoise. Denoising is tricky. It's very easy to over denoise. So the first thing I'm going to do is delete all my previews, because I'll make a new one. I'm going to make a preview of just a general section of space that has a star or two in it, so maybe like this. Okay. I'm going to use a fancy tool called TGV denoise. I have no idea what it stands for, but it works pretty well. So I'm using it in RGB mode because this is a one-shot color image. And one of the things you need to do is you need to create a file called a local support. A local support is basically just a copy of the image, right? So what you do is you take this tab, and then you click and drag it just onto itself or to the side over here or wherever, and it just makes a copy of it. Okay. You also don't want this image, the local support, you don't want it to be RGB. So you go to Image, Extract Lightness. So this is essentially pulling out all the luminosity data and tossing all the chrominance data. And you can see this is a black and white image, and this is not a black and white image. So this is the one we use to extract it. We close it. This, I like to save this as a separate thing, which I just call local support. Okay. And when you right click on it, you can say set image identifier, and you can have spaces for whatever reason. Local support. Okay, there's my local support. So when I click it, it'll say what image is the local support. Well, when I open it, now the choice is local support. So there we go. Okay, so local support. Okay, you can fiddle with these values if you want. I generally don't need to. So now I go to my preview, and I usually use strength -1, edge protection -3 or 4, smoothness -1. I slide the slider around a little bit. So essentially this is a factor of 10. So this is 7.45 times 10 to the -1. This would be 7.45. This would be 74.5. So, it's a log scale basically because they're factors of 10. So I'll just pick, 7, 5, 6 in there. And I'll just do about 200 iterations and see what it looks like. Now, this often takes a really long time to do a full image. So you really only want to do a preview at the time. Oh, one more thing we got to do is totally important. Sorry, I totally forgot. If we do TGV denoise on this image, it will also denoise the non-background things, the stars and the galaxies. So we need to make a mask. And there are lots of ways to make masks in, this is the one I'm working on. There are lots of ways to make masks in PixInsight, but one of the ways that I like is through a tool called range selection. So if you click the little summary, what it'll do is it'll say, okay, you slide these sliders around, this is 100% white, this is 100% black. You want to just move the sliders so that the areas that are white are the things that are selected, and the areas that are the blacks are the things that are not selected, right? So you can select the edge of the galaxies, you can select just the whole galaxies. So you want to make a mask that that selects the galaxies and most of the bright stars, but leaves the background for the most part alone. The reason you want to do that is because you want to denoise the background. You want to make it smooth and blurry, but you don't want to mess up your galaxies, right? So I'll just pick, I think 0.5 was the number I used before. So this is your image. This is what it would look like, or this is what the corresponding mask will look like. Nice big white blobs. The white is the area that is selected. So I click the square, do it. It'll take a second. It'll generate a mask. I can close the preview. Now the mask looks like this, right? So when I take this range mask and I slide it onto here, it will apply itself to the image. In doing so, right, the red is the area of stuff that will not be affected by whatever it is you're doing. The white will be the area that is affected. Well, we want the background selected, and we don't want the galaxies selected. So if we go to mask, invert mask, now it blocks out all the galaxies, and everything that is not red, i.e. this background area and some of the stars, right? Everything that is not red will get acted upon by whatever tool I'm about to use, which in this case is TGV denoise. So I'm going to go to my preview. See this star right here is red, so it will not get acted upon, but these stars, these smaller ones, are white. They will get acted upon. All right, and I'll just click the triangle and drag it onto the preview, and I'll do my denoise. Because this is a very small preview, the calculation goes pretty quick, and it'll do all three channels, 0, 1, 2, which is RGB. Alrighty. And when it's done, if I like my settings, right, I can hit Control-Shift-Z, or I could do undo, redo, redo, undo, redo. Or Control-Shift-Z, which will let you say, okay, it's a little less blurry. This setting is not strong enough, right? You can see I'm hitting Control-Shift-Z. Maybe you can hear me clicking on the keyboard. It doesn't really change anything. So that means my strength, my denoising strength, was not strong enough. So I'm going to go up to 0. So I'll increase by a factor of 10, and I'll do it again. So what I'm trying to do is I'm using the previews to find the settings that work best for my background, and then I'm going to apply them to the whole image. Okay, so almost done. And okay, so now when I hop back and forth, I'll make the image a little bigger. Undo, redo, undo, redo, undo, redo. See how it's nice and blurry here? And the noise is very sharp edged here. You can almost make out the individual pixels. Right? That's kind of what you want. So you can spend a lot of time working on denoise, and that's probably one of the most time-intensive part of processing image, I think, is the noise reduction. But once you have the settings where you think they're pretty good, you go to the image and you apply it to the whole image. Okay, so it's going to take like 10 to 15 minutes, so I'm going to pause the video, and when it's done, then I'll unpause the video and we'll continue. So I'll go ahead and get started. You can see how slow it goes. And I'm going to pause the video now. Alrighty, that was about 5 or 6 minutes of TGV denoise time. So close this tool, put it in the done pile, save the image file as underscore TGV. Okay, and then preview, I'll just delete that because I don't like all these extra previews and stuff hanging around. The mask, remove mask, that will get rid of it. Okay, so now TGV is done. We'll do some LHE next. LHE is another magic step that I like. So for LHE, what I do is I make another preview of just the galaxy. Okay. Let's see, do I need a mask for LHE? Where's my LHE? You can use the same mask. Yeah, you do need a mask. Oops, that was local support. So I apply my range mask, or I can leave it on from the previous step, or if you want, you can make a different mask. So white is the stuff that's selected, red is the stuff that is not selected. To make the red go away so you can see it, you can just hit Control K, which is to toggle the show mask function, right? So it just gets rid of it so you can see it. You know your image is masked because the little tab is brown. If you remove the mask, the thing will not be brown anymore. Alright, so I go to LHE. LHE stands for Local Histogram Equalization. Basically what it does is it allows you to change the histogram, change the stretching of parts of your image as a function of wavelet layer. So click the little circle to bring up the the preview image. And what I usually do is I jack up the contrast limit, I jack up the amount to like almost max values so I know what I'm talking about. So you could see, I'll toggle on and off, on. That's completely absurd. You don't want to do that to your image. But if you change the wavelet layer, which they call kernel radius, right, it selects things in the image based on size. So the biggest thing in this image, this is it working, it's calculating. It's actually doing calculations right now. There we go. Off, on, off, on. Clearly, that's ridiculous. So that kind of sets the extremes for me. Normally, my amount, I think a good value is around 0.2. And then I usually start with about 100 wavelet layer size. It does the calculation, off, on. You can see it brings out a little bit of detail, but not too much. So I'm going to turn the contrast limit down to maybe 30. And I'm going to drop my size down. I'm going to look for smaller scale structures. So I'll go to 75, right? So off, on, helps a little bit. I'll drop down to maybe 50. Do the calculation, off, on. That's not too bad, right? So it depends on the size of the things that in your image, which obviously depends on your image scale. For me, at my image scale, 0.4 arc seconds per pixel, fucking ridiculous. I usually have LHE values around 120, 150. So, but you have a larger image scale, so your things are going to be smaller. So you can see that brings out a decent amount of detail here. And even if you want to go even smaller, maybe like 24, that looks pretty good, right? And of course you can fiddle with these all you want, change the contrast limit. The contrast limit is how much it shows up the difference, right? That's maxed. Actually maxed would be 100% of the contrast limit. That's absurd. I usually do like 0.15 or maybe if your image will bump it up a little stronger. Right, maybe that's a little too much. Right, we'll turn this down to something like that. So you fiddle with the numbers until you get something that looks cool. That's what it comes down to. We're in the aesthetic realm of it now. You can see all this out here is all masked, right? If I do Control K to show the mask. Control K, there's my mask. Oh, the mask doesn't show here. That's interesting. Anyway, you just pick something that looks good. So this area out here is masked. This is where the mask starts to blend, and this is really where the LHE is doing the work, where it starts to show you some structure. So that's what your original image was. Turn the preview on. That's what you get if you applied these settings. I like to check out, Control K. I'd like to check out what that does for all the major parts, so I make little previews for each one. If I apply these same settings to this guy, It would go from this to that. That's not ugly. That's kind of ugly because this right here, that's too noisy for my taste, right? The contrast is good, but that's too noisy. So I think I might go up on the curl radius a little bit, maybe a little bit more. That's a little bit better. Yeah, see, so the noise didn't stand out so much here. And then I'll go back to my other image and see what it does to that one. It's not too bad, you know, it helps a little. Okay, and then I'll check my third galaxy, or your third galaxy. It's okay. And of course you can do multiple iterations of this, right? So you can do local histogram equalization for a kernel radius 74, then make a different mask that maybe only selects the innermost core, and then you contrast that up a little bit more. Depending upon what you have, your image scale and all that kind of stuff, you'll make those kind of decisions. I'm just trying to demonstrate how the tool works and how I use it. Once I have all my settings right, my mask is still applied. Apply it to the image. It does take a minute or two to do, right? Especially in the CIEL, or the CIE mode, the RGB mode. Okay, so do some calculations. Has to apply it to the entire image. And then that would be this. And then the next step is color saturation and then curves. So we're almost done. So color saturation, you don't always have to do. Sometimes you can, sometimes you choose to, sometimes you choose not to. So it's done, so I'll save the image. It has been LHE'd, as I put it. Okay, there's that. Okay, so range selection is done, histogram equalization is done. I think I'm done with screen transfer. I'm done with stretching as well. So last is curves and color saturation. Color saturation. Reset this. So I still have my mask. So let me get rid of all my previews. Delete all. I still have my mask applied, right? So if I just want to change the colors of that, then I just take this and move these values to whatever, right? As it goes up, it gets more saturated. As it goes down, that color, yellow, green, teal, blue, gets less saturated, right? So what I'm going to do is I just want to saturate, let's say, the colors of the stars, right? So not all the stars are selected here. So first thing I'm going to do is I'm going to remove the mask. All right, I still have the file. I can put it back on if I wanted. I'm going to make a new mask. I'm going to make what we call a star mask. So I'm kind of going off script here. So to make a star mask, usually I just use the default settings, click and drag and say, hey, take this image, extract all the stars, and then give me an image file of just those stars. Okay, so that'll do it. And then I'm going to use that star mask as an image mask, right? I'm going to use that file of stars, that image of stars, as a mask. Okay, so let's ever finish this stupid calculation. Okay, come on, son. You don't have to use a mask when you do color saturation, but if you don't, and you don't block out the background in some way, okay, so that's done. If you don't black out the background in some way, then it'll also saturate the background colors, which obviously you don't want. So I take the star mask, apply it, and you can see all the little white dots are the things that are going to be saturated or that my tool will apply to. Right, so it's most of the stars. There's some stars obviously like right here and right here that got missed. You can tinker with the star mask settings. You can see a little bit of this will be applied to, but for the most part it did a pretty good job, right? So the black or the red background is what will not get saturated when I do color saturation. I'll just reset it. I'll do Control K to show us the image. Alright, so let's say I wanted to make the stars more blue. I just click and drag it blue. And you can see this is off, on, off, on. You can see the background gets a touch blue as well. That's okay if it's a little bit, but you don't want to go crazy, right? Same thing here. Let's say I want to make the stars very red. So try to make it a nice even gradient between the two. So you want a sinusoidal based line. You don't want, sharp. You don't want something like this. Right? That would be stupid. So I didn't do color saturation in my previous iteration of this, so I don't think I'm going to do it here. But this is how you do it. You just move these around. You say, this is the yellow spot right here, so I want yellows to be more saturated. This is the blue spot. I want blues to be more saturated. The range is essentially the intensity. So 10 is the most intense, right? So you can see it's stupidly blue everything gets. Or if I do the same thing for the red, and I just try and max out the color saturation, and I'll drop the blue down. Let's say it's something like this, right? Off on. You can see everything gets like a red tinge, which makes it kind of purpley. So reset everything. I'm not going to do color saturation, so I'll just call it. That's fine. And last but not least is curves. So reset all the curves. So you can do red, green, and blue independently. You can do the RGBK component, so the color component altogether. You can do the lightness, which is the brightness. So this is what lightness looks like, right? Just makes the whole image dark and the whole image bright. You can do the saturation, so this does all the colors at the same time, unlike before. So if you tweak the red by a little bit, and then you want to move everything to make it more colorful, you'd increase the saturation. So, you typically do something like this for the saturation. So, all right. So usually the main one is RGBK. So I pull it down a little bit here, a little bit over here, and I make it. This looks ugly. Why does this look so ugly? It looked so much better last time I did it. Oh, because I still have the star mask on. Damn it. See the star mask right here? Forgot to remove it. Mask. Remove mask. There we go. Now when I apply it, there we go. Huge difference, right? So before, after. Before, after. So reset. If I go to saturation, looks retarded, right? You can just see how it's purple. If you want to make a black and white image, you essentially just desaturate everything, right? So that's useless. So if I want to make blue really strong, blue really weak. Red really strong, red really weak, right? So reset all. So RGBK is usually what you do. So I do something like this. You don't want to clip the blacks, right? So you don't want to do stuff like this. That looks fake. And this is just aesthetics. So you just kind of touch the shape of the curve. You want usually to be like a sigmoidal shaped line. So it looks realistic, but not absurd. Can you see this right here? If you can, that's your reflection, I think. You can see what flats does, the lack of flats. Let me delete this point and show you why you need flats, dude. Can you see the pattern? Actually, a better place to see it is with the histogram. So reset the histogram. I'm going to clip the data. There you go. Can you see it now? See, there's like this thing right here. It looks like a big null symbol, like a circle with a line through it. Like that's why you need flats. So yeah, you can see the reflection shining out here. So even though we cropped it, it's still going to show that pattern. And that, of course, that's only going to show up when you do ridiculous, crazy stretching like that. But I mean, it does show its face. All right, so let's do a real curve. So this is our preview. I'll do RGB. Maybe something like that. I'll bump the red just a touch on the high end, touch on the low end. Green, I maybe do the same thing. Blue, maybe do the same thing, something like that. It looks a little blown out in here and here, so maybe the total RGB. Okay, total RGB, we'll try the lightness. Turn the lightness down just a touch. Maybe that's too much. Yeah, see, we're losing our galactic structure when the lightness gets too high. That might be a result of going too heavy-handed on the LHE step. So I'll just pick something like that. So this is before, this is after, before, after. You can see the star colors are kind of weak, just a faint touch of red. So we could tweak that with star mask and stuff. But when you're done, you say apply these settings to this guy. It'll actually do it. Curves doesn't take too long to do. And then I like to save as _curves. And that's usually the final image. And that's what I'm going to send you right now. Just as a heads up, when I did this before I made this video, just to practice, I did version 2, and here it is. Stacked, cropped, ABE, BN, CC, BN again, SCNR, BN again because I wasn't sure where I wanted to do it. Stretched, TGV, LHE, and curved. And this is what I got the first time around, or technically the second time around. You can see how much more green it is, right? So maybe I should do a green wipe on this. I think I like this one better. The blue-red balance here is a little bit better. So if I just do SCNR on this guy, maybe it'll give me a little bit. It might throw off my color balance because this is already post-curves. But actually, that looks okay. So you can see the background brightness levels, right? Like look at this and then compare to this, and I think I like this one a little bit better actually. So I'll save this anyway as SCNR again. I usually don't SCNR after all the noise reductions and the curves. It's usually one of the first things I do. But I'll send you both of these right now. You can look at them.